Hello everyone from Math 1340, Statistics. It's Professor Wenson here, making a video today on section 1.2, Data, Sampling, and Variation in Data and Sampling. Alright, so in this video I'm going to be showing you where you can find the assignment for this section, the reading, some videos, and then go through the KnewtonAlta section, the KnewtonAlta homework for this particular section. Alright, so here I am. This is a Canvas page for Math 1340. Now, again, no matter what section you're in, R1602 or whatever, R1604 or R1612, you're going to see the same stuff. Now, I'm not in the student view here. I'm in the teacher view, but you'll see the same modules. And in the week 1 module, you should see the page for section 1.2, Data, Sampling, and Variation in Data and Sampling. So in that page, as with every page, you'll have 3 things highlighted. One is, read. I'd expect you to read the section in your OpenStax book. Read section 1.2, and there is a link. Click on that link, and it'll open up your the openstax.org to section 1.2 of your statistics book. And just like any other textbook, you got bold words. Read those. I'm not going to read it to you. Okay, I'm going to leave the reading of the OpenStax book sections to you. But look at the highlighted, the bold words and definitions. Read through examples. Do the try-its on your own. Maybe even practice the examples too, before you look at solutions. Now, there aren't any solutions provided here this time like there were in 1.1. But you got all these examples to read, ones you can try on your own, the try-its. See these ones. Now, there are some examples, as I mentioned, with the show solution. I would recommend you try to figure it out on your own first from what you've read, and then show the solution after you thought about it, and then see how you did. So lots of examples and gray boxes here, notes, try-its. Okay, and then another section on qualitative data, charts, graphs. Okay. And then sampling. This will be an important part of the KnewtonAlta assignment and types of sampling. Things to, some calculator instruction if you need to use it. Get to know this stuff here, the types of sampling. There's stratified sampling, cluster sampling, systematic sampling, convenience sampling is kind of a bad kind of sampling. What does it mean to sample with replacement, without replacement? All right. Sampling errors, sampling bias, non-sampling errors. Okay, and some examples and try-its and whatnot. Now, again, you don't have to do all this. Just at least read through the section, variation in data. This is a much longer section, as you probably already noticed, than section 1.1. Alright, so there's that. I'll leave that to you. And of course, do the KnewtonAlta homework, and here's a link to the KnewtonAlta section 1.2 homework. Watch some videos. Now I have the objectives from the KnewtonAlta homework. I have every objective listed and a link to a video. You can just click on the link, it'll take you to the YouTube video that I'm referring you to. Now these are videos that other people have made, not me, not myself. This one has a couple videos. This objective has one, this objective has one, and so on. Right? You can watch those if you want first, after reading the homework, and then go into the assignment. But you can always go right into the assignment as well. Alright, so I'm going to do that. I'm going to click on the link to the KnewtonAlta homework for section 1.2. Might show up in screen for you. For me, it's going to ask me to or load in a new tab, launch in a new tab. All right, now I'm in, again, a teacher view, not a student view. So let me show you what this will look like as a student. All right, so I'll preview as a student. All right, now section 1.1 kind of eased you into KnewtonAlta. It just had one objective. I mentioned that every single one of these KnewtonAlta assignments will have, anywhere from 1 to 6 objectives. So here comes our question. You have the title again, the mastery bar telling you how far along in the assignment you are. And then here's a question, and here's the objective that this question is about. This question is related to. The objective is identify stratified, cluster, systematic, and convenience sampling. And you can see how far along you've gotten on that particular objective with this little circle and star next to it. Also, if you'd like to see the other objectives and how far along you are in those, what's your progress, click on this down arrow, and you see that this particular section of KnewtonAlta homework here has 1, 2, 3, 4 objectives to complete. All right, and an estimated number of questions for each each part of the assignment. Okay. Now, let me talk about this objective here. These types of sampling. Sampling is, remember from last section, you have a population, which is the entirety of what you're trying to study. And if you just select a portion of that population, that is a sample. Well, the way that you select that portion of the population, that's called sampling. All right, pulling a sample. So I would recommend, as I did with the last video, every time you come across a new objective, right, and you can tell that it's new because you haven't, there's nothing filled in on the circle. I would click on More Instruction if I were you. Unless you did the reading in OpenStax and you feel comfortable and you watch the videos back in the Canvas that I had up. If you did that reading and watched the videos and you feel comfortable that you know the material pretty well, you don't have to go to More Instruction. But if you're still not comfortable, here's this third resource for you to read and study from. And also, if you're struggling, not just if you've seen an objective for the first time, but also if you're seeing a problem that you're having an issue with, you're having trouble with, click on More Instruction, and then View Instruction, and it takes you to instruction. It'll be some text or maybe videos on the objective that question is about. All right, so the types of sampling. All right, so a random sample is one in which each individual in the population has an equal chance of being selected for the sample. All right, so everybody in the population has an equal chance of being selected. A simple random sample is a sample selected from a population in a way such that all combinations of members of the population of that size have the same chance of being selected, right? So say a simple random sample of size 5, that means that every possible group of 5 people in the population has the same chance of being selected. All right, so I'm not going to watch this video. I'm not going to have you watch a video within my video, but there is a video here for the types of sampling. I'm just going to go to the definitions and actually show you what some of these mean on a piece of paper. Right? So some key terms from the video. Convenience sampling. So this is a type of sampling that is not random. And if it's not random, that's not a good thing. All right? You want your sampling to be random so that way your sample has a better chance of being representative of the population as a whole. So convenient sampling is a type of sampling that's not random and involves using a population that is readily available. A related term is quota sampling, using a sample that is selected to match the population with respect to some specific characteristic. All right, so convenient sampling would be if I were to, collect a sample and all I did was, stand outside a store and just wait for people to come into it, or go to a local coffee shop and just interview, collect data from the people within my grasp, and it was convenient, it was easy, readily available, not random. The same thing with quota sampling, right? You're trying to, it's where you select a sample, but you only select people from the population of a certain type of characteristic. You don't get a random sampling. All right, now I want to talk about the difference between cluster sampling and stratified sampling. People often confuse cluster sampling and stratified sampling. Cluster is divide the population into groups, then randomly selecting some of those groups. All right, so let me show you what I mean by that on a piece of paper. Okay, so on my paper here, we're talking about cluster sampling. So suppose this group of little figures, little dog and cat figures I have here is my population. All right, so what cluster sampling is I break the population into groups. All right, so here we go. I've broken the population into groups. All right, so 1, 2, 3, 4, 5, 6 groups. Cluster sampling is now that I've broken the population into groups, I randomly select so many of these groups to be in the sample. So say I were to roll there's 6 groups, say I rolled a die and I take group 1, you're in my sample, and group 6, you're in my sample. And I roll a die, roll a 1, and I take this group to be in my sample, the entire group, and I roll the die again and I get a 6, and I take this group to be in my sample. So now my sample is made up of those 2 entire groups. Right, here's my sample in my hand. I leave the other groups alone. I do not touch them. Okay, that is cluster sampling. Now that's a little different from stratified sampling. Right? In stratified sampling, you divide the population into groups, and then taking your sample from a proportionate number from each group. So you take a little bit from each group. And again, let me show you what that looks like on paper. Okay, so back to the paper. So again, say this group of cats and dogs is my population, everybody I'm trying to study. Stratified sampling is, again, I start the same way as cluster. I break up my population into groups, right, or strata. All right, the groups in this case will be called strata, which is the plural of stratum. Right. So again, let's just do 6. It could be as many groups as you wish. So I break up the population into groups, and then I take a little bit from each group. I take a little from each group, not taking entire groups. I take a little from each group. So when I go to collect my sample, say I take 1 from each group, 1 of this, 1 of this, 1 from group 3, 1 from group 4, 1 from group 5, and 1 from group 6, and there. What I hold in my hand is a sample of the population, and it's called a stratified, or the way I just collected it is stratified sampling. I break the population into groups, and I took a little bit from each group. All right, so can you see the difference between this and cluster? All right, cluster was break into groups, and then you take entire groups, leaving some other groups alone. All right, so let's go back back to the instruction. All right, so that was cluster and stratified. All right, next is systematic. Systematic sampling is randomly selecting a starting point in a list of names and then taking every nth piece of data from a listing of the population. All right, systematic sampling is a special subset of cluster sampling. All right, so let me show you a systematic on a piece of paper as well with the cats and dogs. Okay, so back to the paper. So here I have lined up a bunch of the cats and dogs. Say this is my population of cats and dogs, the ones I'm trying to study. Systematic means to fill in my sample, to collect the sample. I first pick one of these at random. All right, so let's say I roll a die, or I use my calculator or a random number generator, and I randomly select the 12th animal. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So like I'll start here. Right, there's the 12th animal. So this animal will be in my sample. And then systematic sampling is, say I go every, let's say I take every 4th animal until I get a sample of 7. Let's say I'm just throwing random numbers out there. So starting here, this animal's in my sample, then 1, 2, 3, 4. This is in my sample, this animal. 1, 2, 3, 4, this animal. 1, 2, 3, 4, this animal. 1, 2, 3, 4. That's 1, 2, 3, 4, 5, and then 1, 2, 3, 4, and then 1, 2, back to the top, 3, 4. There's 7 animals. So those ones I underlined in red are going to be in my sample, so I take those. And here's my sample. All right, now I've got my sample of 7 animals in my hand. All right, and this is what I'll study from the population. Yeah, so you start at a random spot, and then you count every 5th person, every 4th person, every 10th person, until you get the sample size you wish. Like here I wanted 7 animals. All right, that's systematic sampling. Okay, so we got the types of sampling down. And now that I'm done with that instruction, and again you can watch the video yourself, I hit continue for some questions, right? Some questions related to this topic. So Annie wants to estimate the average number of AP classes at her high school takes. A student at her high school takes. She decides to randomly select 6 classes and use all the students in those 6 classes to estimate the average. So what type of sampling did Annie use? This is cluster sampling, because there's more than 6 classes. She's breaking her school up, the population, right? All the students in her high school, into groups, into classes, and then taking 6 of those classes and leaving the rest alone. Right? So that's an example of cluster sampling. Now again, I said this in last video. I'm in the teacher mode here. You will not have the instructor cheat button. All right, so I hit submit, and it's like, yes, that's right, keep it up. And again, if you get it wrong, it'll still have a word of encouragement, and just throw more problems at you until it feels you've mastered it. And an answer explanation. All right. Continuing. Here's another question related to that same topic. Sneha, how you pronounce that, wants to inspect the cleanliness of the rooms in a hotel. There are 10 floors in the hotel, and each floor has 20 rooms. From each floor, she randomly selects 2 rooms and inspects them. What type of sampling was this? So here the population is the total number of rooms, right? All 200 rooms in this hotel, 10 times 20. Well, she's not going to look at they're not going to look at them all, right? They're only going to take a sample. And what's happened here is the rooms were broken up into groups, into floors. And then 2 from each floor, 2 from each group was selected. So this is that stratified sampling, right, where you take a little from each group that you broke the population up into. And there, I'm done with the instruction. Then it comes back and look at this. I'm already halfway. It looks like about halfway through that objective now. Right. Okay, and I'm still on the same objective, and it now brings me back, gives me a question. This is just true or false. And again, don't guess, because if you guess and you guess it wrong, it's just going to keep throwing more problems at you, and it'll take longer to get through to the 100% mastery. In reference to different sampling methods, cluster sampling includes the following steps. It says use simple random sampling to select a set of groups. Every individual in the chosen groups is included in the sample. This is correct, right? This is where everybody in the groups you chose is taken. That is that cluster sampling, right? Not a little bit from each group, but everything in the groups that you selected are taken. This is correct. This is true. Right? That is cluster sampling. All right, and moving on. Okay, here it is again, another one, continuing on with the bar. Again, now I've mentioned this in the last video too. There are lots of problems in KnewtonAlta, so the problems I'm seeing aren't going to be exactly the same or in exactly the same order with exactly the same numbers as the ones you see. All right, so don't just think that, don't just copy what I'm doing all the time. All right, actually pay attention, read the question, read the instructions, and yeah, so just know that you're going to see something possibly a little different than what I'm seeing and what other students are seeing as well. All right, to study the mean blood pressure of all people in her state. Right, so that's the population, and the variable is blood pressure. Right, what this person's recording. Christine samples the population by dividing the residents by towns and randomly selecting 9 of the towns. She then collects data from all the residents in the selected towns. Well, geez, that's cluster sampling again, isn't it? Broke up the population into groups, broke it up into towns, and then took 9 of those towns, all of the people in those towns, not just a few. That's again that cluster sampling. All right, and now you see once you've completed an objective, hey, this confetti drops. Like I said, you won't see the exact same questions I do. And you might get some questions about, systematic sampling or stratified sampling or convenience sampling. But if you ever have trouble, just click back on more instruction, or maybe even take go back and read the OpenStax section again, watch the videos again, and if you're really struggling, take a screenshot of the problem and send it to me and ask me if I could help you out. All right. But there's lots of stuff you can do before you get to talking to me or talking to a tutor. All right, so now I continue and move on to the next objective. Now it's again a new objective. Identify sampling errors and bias. And it's new because the circle's not filled in. Right now, look, I'm a quarter of the way through. I did one of the 4 objectives. Again, I'm seeing a new objective, so I'm going to go to more instruction, view instruction, right? And no videos this time, right? So I'll actually read to you some of these and explain them if I can on a paper if I need to. So samples that contain different individuals result in different data. When you analyze data, it is important to be aware of sampling errors and non-sampling errors. Sampling errors are caused by the actual process of sampling, right, the way you actually collect the sample. For example, the sample you choose may not be large enough to truly show information about the population you need, right? If you're studying everybody in your state or everybody in the country and you only select a sample of 10 people, that's not going to tell you a whole lot about your state or your country. Because the populations are pretty huge. Just taking a small sample won't tell you a lot. In reality, a sample will never be exactly representative of the population, so there will always be some sampling error. As a rule, the larger the sample, the smaller the error, right? Because the bigger the sample is, the closer it is to being the whole population, right? So the less error you will have in your sample. Non-sampling errors are caused by factors not related to the sampling process. Right? For example, a counting device that is defective and incorrectly counts subjects can cause, this is like machine error, clerical error, machine failure, the recording human error, like the way that maybe a person who was recording data accidentally threw in an extra zero or messed up the decimal point or whatever. Non-sampling errors. In statistics, each member of the population should always have an equally likely chance of being chosen for the sample. That's why I said earlier about if a sampling method is not random, right? Like convenience sampling or quota sampling, that's not good. That has a tendency to create what's called bias, and they should be conducted without creating bias. Bias is when an individual's opinion or preference influences the results of a sample. Right? There's a couple kinds of bias they mention here. A sampling bias is created when a sample is collected from a population where some members of the population are not as likely to be chosen as others. When a sampling bias occurs, the conclusions drawn about the population can be incorrect. For example, if you wanted to determine what your city's favorite sport is, and you only sampled people at a Major League Baseball stadium, sampling bias would be present in this study, right? Because you would suspect that people at the stadium would say that baseball was their favorite sport, and your whole sample would lean toward baseball, when you should be asking people from all around the city. Right? Number 2 here, many different parts of a study can be affected by bias. Bias can be present in the sample chosen, the phrasing of questions, the environment in which a study is conducted, etc. There's lots of ways that we can induce bias. For example, the Banana Beverage Corporation conducted a taste test to determine whether customers prefer drinks by Banana Beverage Corporation, or drinks by their competitor, Strawberry Soda Corporation. Here, the person conducting the survey has a bias toward Banana Beverage Corporation. So the study is said to be biased, right? If this was a study done by a third party, then we'd consider it a better study. But this survey is run by one of the companies in the survey, that kind of raises an eyebrow and makes you think that there might be some bias or some preference for one over the other. All right, and I've already read all these. Sampling bias, sampling error, non-sampling error. Okay, now let's continue into the questions. Right. So here's which of the following scenarios contains a sampling error. All right, so now it says select the correct answer below. All right, only one. So let's read them. A study is conducted to determine the favorite subject of all the students in your high school. Students in your homeroom class were used as a sample. I would think that this might cause a sampling error because you're trying to determine the favorite subjects of all the students in your high school, but you're only taking students from your homeroom class, one class. So there's sampling, there's a possibility for, well, that's more like sampling bias actually, where not everybody in the school has an equal chance of being selected. So I'll save that. I'll say it's that for now. Let's see what the other ones look like. A study is conducted about where the best travel destinations are, Europe or Asia. People who live in big cities throughout Europe were used as the sample. Again, that would kind of be more toward a sampling bias, right? Because you got but it could also be sampling error, right? Because the sample is not the whole population. the error caused by the actual process of sampling. Okay. Because here you're pulling people from Europe, but it's like they're asking a question about, you know, Europe or Asia. Like you would think they'd be like, hey, the best travel destinations are in Asia maybe, or in Europe because they live in Europe. All right, number 3. A hospital conducts a study about a new heart monitoring software. All patients who use the software were used as a sample. Well, that's pretty good. If every single patient who used the software was in the sample, that's the entire population. A study is conducted by a cereal manufacturer about 2 brands of cereal, and a question on a survey read, do you prefer the delicious taste of brand X or the taste of brand Y? All right. Now again, this is more bias than sampling error, because there's definitely bias, a lean toward brand X in the question. So I'd say this is more bias, right, because there's preference for one over the other. I'd say this is perfect, right? This is like, this is the population, you know, you very little sampling error there. This one is again more about bias, I would say, than it is about sampling error, because it's, you know, Europe, people in Europe, the questions, people in Europe are used as a sample. I'd go with the first one, because again, you know, you're not getting a really good representation of the whole high school if you're getting students in one class. And yeah, so looks like that's correct, right? Like I said, these other ones, the second and fourth one, are more about sampling bias, or more bias, where you're leaning more toward one thing or another. Third one was perfectly fine, right? And yeah, the answer explanation leaves much to be desired. Okay, so I'm done with that question. Looks like I'm about I was about a quarter through that one. Right, we can check here. So I'm about a quarter through this, but now I'm in a new objective. Oh, you know, see, it tosses you around, and like I said, you know, it might do different order for me than it does for you. Right, I'm just doing this as a kind of a guide through how KnewtonAlta assignments work. All right, so this objective: identify situations in which statistics can be misleading. It can be, you know, like lead you in one direction that it shouldn't, right? Lie to you. Right, so again, new objective. Haven't made any progress on it yet. I'll go more instruction. Misleading statistics. All right, now there is a video here, but I'll just read over the key, you know, the key terms from that video. I'm not gonna watch a video within the video. Bias. I've already talked about the word bias, right? Error present when data is collected from samples which are not representative of the entire population under study. We talked about bias a little bit already. When there's an outlier present, you have a chance for some misleading data. An outlier is a data point that is distant from all other data points, right? So if all my values, if all my data were around 75, let's say 74, 73, 77, 72, 75, and then there was one piece of data that was like the number 4, that would throw off an average, right, quite a bit. It would throw off your variance. It would throw off a lot of things if that number 4 was allowed to continue to be in there. So an outlier is just a data point that is distant from all other data points. Just a couple simple definitions there. All right. So now to a question. There are more people who volunteer in soup kitchens in the state of California than in the state of Arizona. Therefore, the people in the state of California are more willing to volunteer their time than the people of Arizona. Is there a problem with this logic? Well, yes, there are many more people in California. Right? California has a greater population than Arizona, so it's only natural that there would be more people volunteering in soup kitchens in California. The percentages might be similar, but the numbers would be greater. So yeah, I'd say so it's either one or two. Yes, there's a problem with the logic. You know, more people in California live by a beach and are therefore more willing to volunteer. I don't think it has anything to do with them living by a beach. California has more residents than Arizona. Therefore, there is a likelihood that there will be more volunteers in soup kitchens as well. That makes sense as to why the logic is flawed. All right, continue. All right, so another video here. Still.
Let's talk about misleading statistics.
Still the same instruction. Continue. Here's another question about the same objective. There are 4 major toothpaste brands. Awesome Brush A, Brushtastic B, Cheery Brush C, and Dental One D. A survey of dentists is done which asks which brand they recommend most highly. Which of the following graphs are misleading? All right. You got a lot here. Now, it says select all that apply. This first one. Now the numbers are there, but they'll tell you in any statistics course. You see this scale on the left side? How it doesn't start at 0, it starts at 20? If you don't start at 0, that can give you a misleading picture. Because do you see here how it looks like A has twice as many dentists that prefer it as D, right? The bar is almost 3 times as high. But the numbers are actually not that. You have 60 for A, 35 for D. 60 is not more than twice 35, right? 60 is less than double of 35. So the bar here is deceiving. All right. So yeah, if you're looking at a graph and a scale does not start at the number 0, and the numbers aren't evenly spaced, it's misleading. It can give you a misleading picture. This one's perfectly fine. You got the brands, the scale starting at 0, everything's nice and evenly spaced. This is perfectly fine. It is not a misleading graph. This one is a little messy. Yeah, it starts at 0, the scale, but the numbers on the scale are not evenly spaced. Sure, these are 5 apart, but then this block here is 25 apart. And it makes you think, just because if you didn't look at the numbers, it would make you think that brand A and brand D had very similar numbers, very close, but they're actually 25 off as opposed to 5 off, which brand B and C are only 5 off. So this is misleading because of the scale on the side. All right. I guess the pie charts. The pie charts, like this first one, has the 4 categories represented, and then an other category, which is usually in pie graphs when, because these aren't the only 4 brands of toothpaste, right? They just say there are 4 major toothpaste brands. And, if a dentist are asked which brand they recommend most highly, they could say other. And all four brands are represented. I would say at the moment, I may be wrong, but that this is not a misleading picture. Usually the percentages are mentioned in a pie graph, but let's say that's good for now. Oh, here, this is misleading. It's not giving you all the information. Brand A isn't represented. Same here. Brands C and D are not represented. So I say these last 2 pie charts are misleading. And let's see, I'll submit these and look. Yeah, great. Again, just look for bar graphs, look at scale, and this stuff is mentioned in either the video or in your OpenStax reading, right, about charts from section 1-2. Great. And they have some they have explanations here as to why they're misleading afterwards. All right. So read the answer explanations too if you're still unconvinced. All right, so now I'm back to all right. So now I'm back to this identifying sampling errors and bias, which I'm about a quarter through. Now, which of the following scenarios contain biased samples? Select all that apply. Remember, bias, leaning more toward one way or another, or if it's a sampling bias, means that not everyone in the population has the same chance of being selected. So select all that apply. All right. To estimate the mean number of classes that students take at his university, Benjamin collects data from a randomly selected proportionate number of students from each grade level. That sounds pretty good. You know, break it up into grade levels and then taking a proportionate number. That's that stratified sampling. That was a good kind of sampling method from earlier. So I'll say that's fine. Howard wants to estimate the mean weight of people in his town. He collects data by interviewing members of a fitness club. That's a little biased, right? Because not everybody in their town is going to a fitness club, right? You got to also include people that don't work out often or aren't members of a fitness club. So there's definitely some bias in the way that that sample was collected. To estimate the political party distribution of residents in his state, Sean collects data from a large group of randomly selected residents of his city. Another more sampling bias here, right? The population is the state. So if you pull residents from just a city, that doesn't give everybody in the state an equal chance of being selected. So there's definitely sampling bias in that. Teresa wants to estimate the mean amount of money spent on clothes per week by mall shoppers. She collects data from every 10th person entering a clothing store at a mall. All right. Now that would be more of a convenience sampling, but if she randomly picks the first person and goes every 10th, that would be like the systematic sampling. So let me think about this for a second. And remember I said earlier about, again, much earlier in the video, about convenience sampling, when you're like just sitting at a coffee shop and interviewing people there, or standing outside a store. Like, that's convenience sampling. That's not really that random. So not everyone. What about and there might be some other entrances to the mall that you're not getting. You're not really getting a nice representation of the population of mall shoppers. So I'd say that was more convenience sampling or quota sampling, and there's chance for bias there. All right, I'll submit and hooray. And again, read the now the explanations there. Great, and you got the explanations. Yeah, the sample from choice D is biased because mall shoppers that do not visit this particular store are not represented. So it's kind of like how, the city versus the state. There are other malls too that you have to consider. Didn't think of that, but still a bias sample. All right, so another question on identifying sampling errors and bias. So again, select all that apply. Select all of the following scenarios below that contain non-biased samples. Right. So again, read, pay attention. To estimate the political party distribution of residents in his state, Frank collects data from a large group of randomly selected residents of his city. That is biased. We had the exact same kind of thing with Sean in the last problem. People in the city won't represent everyone from the state that well. The mean number of classes is, all right, this one was the grade level, right? So randomly selected proportionate number of students from each grade level. I'd say that was non-biased. That was actually good. A good way to collect the sample. David wants to estimate the mean grade point average of students at his school. He collects data by recording the grade point average of every 25th students on the list of students after randomly selecting the first student. Now this is good. This isn't like the every 10th person at the mall. This is from a list of the entire population. So, the one where she was interviewing every 10th person at the entrance of a mall, she wasn't at every mall. She didn't have the population, but this person does. David has the entire list of all the students, randomly selects the first one that goes every 25th. That's that systematic sampling, and that is a balanced, a good way of sampling. I'd say that was a non-biased sample. That's good. Helen wants to estimate the male to female ratio of residents of her city. She collects data by recording the sex of every 50th resident after selecting a random starting point on a list of all the residents. Again, this is very similar to the second one, so I'm going to say that's also a good method of sampling, a systematic sampling. Wonderful. All right. It's a great work. All right. Correct answer and all that. And explanation, right? Please read the explanations, get some more instruction there. All right. Again, so the same objective. Select all the following scenarios that contain biased samples this time. Kelly wants to estimate the mean number of calories consumed by students at her school. She collects data from randomly selected individuals in the cafeteria for breakfast. Just the individuals in the cafeteria for breakfast. Not everyone goes to breakfast. Maybe maybe they eat it before they come to school. I'd say this was a biased sample. Not everyone has the same chance of being selected. To estimate the ethnic background distribution of residents of her town, Deborah collects data from 1,000 randomly selected town residents by using a random number generator, and that's great. And it's from the town residents, and she's doing it for her town, right, not for the entire state, and it's randomly selected. Everybody's got the same chance of being selected. That is unbiased, so I'm going to leave that one alone. All right, this is like the mall person again. Mall shoppers. This time it's Paul instead of Teresa, right? Yeah. Collects that's definitely biased, right? Convenience sampling. Convenience sampling is not random. It's not good. Homer wants to estimate the mean grade point. All right, so this is like the last problem, only instead of something I forget what the other person's name was. It was Homer this time. Every 25th student on the list selected after randomly selecting the first student, and he's got the whole list of all the students. So he's got the whole population in front of him, and he's doing systematic sampling, which is a valid way of collecting a sample. So that's not biased, not biased. So I'll leave it alone. So the 2 and 4 are good. 1 and 3 do contain bias, I would say. Wonderful, great. That objective is complete. Hooray! 2 of the 4. Continue on. All right. Now I'm halfway done. Looks like with identify situations in which statistics can be misleading. So again, this is the bias versus outliers, right? Bias and outliers could cause misleading stuff, misleading graphs too, right? We saw the bar graphs and pie graphs. All right. So Tina collected data from a random sample of 600 students in her university, asking whether or not they exercise more than 30 minutes per day. Based on the results, she reports that 53% of the students in the nation exercise more than 30 minutes per day. Why is this statistic misleading? Well, look, she collected data from a sample of students in her university, and then her conclusion was that 53% of students in the nation. That's much, much larger than her university. She only pulled people from the university, not the entire nation. There's definitely bias there, right? You could say the sample size is insufficient, but 600 students is a lot. I mean, usually an insufficient sample size will be we'll consider usually under 30, sometimes under 50. 600 students is a lot of students. That's not an insufficient sample size, but the sample is definitely biased meaning, because you're not, the chances of everybody in the nation being represented by students in her own university is very slim. Okay, so I'll submit that. Looks good. Right. Hope that made sense. And again, the explanation. All right, so another one. Well, it looks like we're close to finishing this objective. Rebecca collected data from a random sample of 500 homeowners in her state, asking whether or not they use electric heat. Based on the results, she reports that 51% of the homeowners in the nation use electric heat. Again, this is the same problem. This is exactly the same problem. Just because you're pulling a large sample from your state doesn't mean you're representing the nation as a whole. So again, there's bias. And it looks like I've completed another objective. Right. Again, you might see different problems. Just go through them the best you can. Let me know when you have problems if you've exhausted all the resources. All right. Finally, now this last one we haven't touched yet. All right. One more objective. new objective, define and distinguish between qualitative, quantitative, discrete, and continuous variables. And let me go to more instruction since it's new, and view instruction. Now there's another video, okay. Key terms. Qualitative data, the result of categorizing or describing attributes of a population usually described by words or letters. Qualitative data is also referred commonly to as categorical data. So this is when colors, like if I said if I started recording the colors of my M&Ms, if I pull a sample of M&Ms and this one's brown, this one's red, this one's blue, brown, red, blue, colors, labels, words, categories. Quantitative data is quantity, numbers, right? The result of counting or measuring attributes of a population always described by numbers. All right. It looks like that's all, right? Now another part of the title of the objective was on discrete and continuous data, right? Which you should be seeing here, right? In section 1.2. So not everything in the more instruction is taken directly from the OpenStax books, but you can always, you should always, I would recommend having the OpenStax book open as well. So again, qualitative, categorical, quantitative numbers. Now, quantitative data are the result of counting or measuring attributes of a population, right? Getting numbers. If you are counting, right, 1, 2, 3, 4, 5, something that is counted, all data that are a result of counting are called quantitative discrete data, right? 0, 1, 2, 3, and so on, right? If you count the number, an example is you count the number of phone calls you receive each day for the week. Data that are not only made up of counting numbers, but that may also include fractions, decimals, or irrational numbers are called quantitative continuous data. Continuous data are often the results of measurements like lengths, weights, and times. So just simply counting numbers is discrete data, and numbers that are measured, usually with a special tool, like you measure length with a ruler, weight with a scale, time with a clock, measurements that can take values other than the counting numbers is continuous data. All right, so back here, continue. All right, so which of the following surveys have quantitative data? Quantitative, numbers. Right? Select all that apply, so multiple answers. All right, a 2013 CDC survey on youth fitness asked students which sports they enjoyed the most. Baseball, golf, and gymnastics are possible answers. This is qualitative data, labels, categories, not quantitative. So not that one. 2015 Gallup survey about free expression on campus asked students which news sources they follow. So like, CNN, Time, Fox, those are labels. Those are qualitative, not quantitative. A 2015 CDC survey on family growth asked women how many times they have been pregnant. That's a number. 0 times, 1 time, 2 times, 3 times. That's quantitative data. A survey on youth health asked participants for the number of sports they played in the previous week. Number of sports. Number. Quantity. You can answer with 0, 1, 2, 3. That's also quantitative. All right. And again, read the explanation. All right. Oh, here we go. Discrete versus continuous. The second part of this. All right. So you could watch a video if you want. So I guess it is in here, but I went back and showed you here. But they talk about the difference between discrete versus continuous. Again, discrete, counting numbers, 0, 1, 2, 3, 4, something you can count. Continuous, something that has to be measured, length, weight, volume, height, time, etc. So I continue. Again, watch the video on your own if you wish. All right, so which of the following data is continuous data? So again, select all that apply. So 2015 CDC Family Growth Survey also asked women how many cigarettes they smoked per day. Do you need to measure that with anything special? No. There's 0, 1, 2 cigarettes, 3 cigarettes, 4. That's counting. That's discrete data, not continuous. A survey management company measured. The key word there is measured. Right? If it's measured by some special tool, measured how much time each participant takes to complete a survey, that's something that's continuous data. An environmental researcher measured the average length, right, of the fish in a certain length. That's also continuous data, those measurements. A librarian counted, discrete, counted the number of books, right? Number of books is 0, 1, 2, 3. That's discrete. So just those two, the 2 and 3, are continuous data. All right, almost done there. Almost done. Look at how close I am to the master bar. 88% done. All right, question. Given that Angelina is collecting data on commute distance, what type of data is she working with? Distances, right? That's length, that's miles, that's something that is measured by an odometer in your car, some special thing. That's definitely continuous. So it's not qualities. It's quantitative, sure, it's numerical, but it's not discrete. It's quantitative, right? It's numerical, distances, and it's measured, lengths that are measured, continuous, right? So continuous, quantitative. It looks like I might have one more here. Yeah, maybe two more. Looks like what term best describes data that is an attribute whose value is indicated by a label, words, qualitative, qualities. All right, probably one more. Nope, looks like I did it. There, I finished it, got 100% mastery, went through those 4 objectives. Hopefully this was informative. Hopefully you learned something about sampling, about discrete versus continuous data, qualitative versus quantitative data, what's bias, outliers, sampling methods, lots of stuff here. And yeah, hopefully this was informative, and I hope you use it as a nice little guide to help you when you're going through the assignment as well. And again, you're going to see things probably in a different order than I saw here. All right, I'm just doing these all the way through kind of just as a guide for you. If you want to watch my video first and then go through and try and do the assignment on your own, or do the assignment while you're watching my video, like in 2 different tabs, be my guest. But hope it's informative, and if you've read the book, read the OpenStack section, you've watched the videos in Canvas that I put up under the watch, and if you've clicked on more instruction for every problem you had trouble with or every new objective, if you've done all that and you're still having trouble, then go see a tutor or come to me with your questions, and maybe take some screenshots of the problems you're having problems with and send them to me and ask me about them. All right, but I hope it doesn't come to that. I hope that I've given you enough to where you can get through this on your own with a little guidance from the videos and the reading. All right, thank you for watching.